Hello, everybody. I'm your host, Noz Urbina, and this is OmnichannelX's Omnichannel Podcast. OmnichannelX is brought to you by Urbina Consulting. OmnichannelX is our international learning portal where we host the thought leaders and case studies we think will be most helpful for content-rich organizations trying to build better relationships across all touchpoints. Now, enjoy the show. Hello, everybody. My name is Noz Urbina. I am the program director for OmnichannelX and host of the OmnichannelX podcast, also founder of Urbina Consulting. I'm here today with Yanko Ivanov, who works for a company that Urbina Consulting partners and collaborates with on a regular basis, Enterprise Knowledge. Yanko, do you want to tell the audience a little bit about yourself?
Sure. Thanks, Noz. Thanks for having me today, talking with you. Like I said, my name is Yanko Ivanov. I'm an enterprise solution architect with Enterprise Knowledge. I've been doing this for quite a bit, but content management, content delivery, semantic solutions, those pieces have always been part of my career from the very beginning, both from the technical side of things as well as down to the business implementation, business goals. In the most recent stage of my career, I've really been focusing on the structured content and semantics, how these areas overlap. And I'm really excited to talk to you about it.
Awesome. Yes. So Yanko and I, we work together. We have very interesting Venn diagrams of our backgrounds and our skill sets, and so we do. And we also, I think, one of the things interesting is we both work on that boundary between the technical people and the business people. So very interested in how the business is going to derive value and how they are going to operationalize solutions, but we do have some technical background. So what we're going to be talking about today is various ways, essentially at the highest level, various ways of organizing your content. So we're going to talk about domain and content modeling, ontologies, knowledge graphs, and of course, no conversation today is complete without some mention of AI and large language models, aka ChatGPT and the like. So to kick us off, I want to start with a topic which is very interesting for me, and we're getting a lot of demand and interest these days, domain and content modeling. So I'm going to define those, and then we're going to see where does domain and content modeling end, and where do things like ontologies, knowledge graphs, and all that other stuff that's coming up begin. And that's what we're going to switch over. So to start with, kicking off with a domain model. So when we're doing domain modeling in projects, what we're talking about is figuring out the relationship between all the key things in a subject domain. So there's a lot of, there can be sometimes confusion between the word domain, like I'm speaking now in terms of a subject, like a domain of expertise or a domain of knowledge, and a domain like a URL. So we're not talking about web domains. Although you may use this for your web content, we're talking about in the sense of like a domain of expertise or a domain of knowledge. What are the things that we're talking about? So if we were in the pharma domain, we would have drugs and prescribers and patients and conditions and side effects and so on and so on and so on. So the reason we start with domain modeling is because we're building the key and important relationships between the key concepts in this area. And incredibly, this is often not done when we're doing content. People just kind of launch into projects and start creating content, but have not thought of the underlying domain and how the different things relate to each other. And there's a lot of benefit that can be derived, because when you take your base classes and concepts that are in your domain, and you start to extend those and say, okay, well, what do we want to say about these things? Then your content model, which is your content types and the structures of your content and how they're related to each other, will be rooted very much in the reality and share the mental model that is existing in the heads of your audience. So I've been content modeling for years, and I used to content model from documents. So I would model, and I would go into an organization and say, well, what are we trying to create here? These are the documents that you're doing. Okay, so let's model these up so you can create them more efficiently. Domain modeling was very powerful because it started to look at, well, before we start modeling to reproduce the status quo, what is the underlying architecture here? Like, what is the logic behind all this? how do people think about it? And so getting into domain modeling and journey mapping to really understand the information and experience space that your potential content consumers and content creators are living in before we start saying how we should package things up into documents. That's been very, very powerful. So I've kind of already alluded to a content model, but let's say, so we've named all our things. So if we were staying in pharma, we've named our drugs, our side effects, things like studies and participants and all these different things and how they all relate to each other, what the rules are around those relationships. Now we get into what are we going to say? So we have, for example, a study may be talked about in dozens and dozens and dozens of documents. It's one thing in the real world, a study, a clinical trial. It is a study on a drug and how it works. But how we may talk about it when we're responding to a patient inquiry, how we might talk about it when we're speaking to a regulating body, how we might talk about it when we're speaking, when a medical professional is speaking to another medical professional who works for the pharma brand. All of these things are different contexts that might require different content types that may or may not share information. So you're going to have consistent things like study names, the participants, design, geographies, other kind of key findings. So there's lots of stuff that you're gonna share, but how you talk about them may be encapsulated in different content types depending on the need and the use case and so on. So that's how the domain model relates to the content model. Once we've got a content model, then we can create this nice, what we call semantic structured content. I constantly use the metaphor of Lego. If you want to Legoify your content and actually build this reusable components that you can take apart and build up different things for different people or do personalization, all that good stuff, then having this meaningful, AKA semantic model behind it is really powerful. You can bake that into your different management and delivery systems so that they all understand what's being operated on. They can deliver much more personalized, relevant, localized, channel appropriate, et cetera, experiences. So that's my kind of area of expertise. I do that all day in, day out, figuring out how we build good domain models and content models so that people can author, deliver this great content. And in the last 6 or 7 years, I've been collaborating more and more with people like Yanko, who do ontologies and knowledge graphs and artificial intelligence systems, recommendation engines, and so on. So Yanko, if the domain model is kind of like our design picture, it's our visualization, our conceptual visualization of what our domain looks like and what the relationships are. Can you take us into where things like ontology and feel free to throw in some taxonomy stuff in there?
Yeah.
What's then the next step, and what's the benefits of going from having a domain model to having a formal ontology?
Yeah, this is really interesting because what you mentioned earlier is having all the content, all the information around let's say a study or even a drug, and being able to present it in various different ways. Now imagine, what if we can actually automatically integrate not only the content about this study or drug, but also actual data. It could be study results. It could be specific data points for the drug or the results or the study that are currently stored in a database, in a very structured data source, data system. When we're talking about content model, this is content. We have whether it's structured content, whether it's rich text and so on. It's actual text mostly, right? We can have images and so on. But the ability to integrate that text with the related data is where a solution like a knowledge graph really comes in. We can get into more detail about knowledge graphs, but the idea is that it connects. It's basically a connective tissue, if you will, the connective layer between various different elements in your enterprise that produce one cohesive view of whatever entity you're looking at. Whether it's
that's the ontology, that's the knowledge graph, or both?
That's the knowledge graph. We'll get to the knowledge graph in a little more detail, but how do we get there? You also mentioned the domain model. So the domain model, like I said, it's really the representation of our world, whether it's pharma, whether it's a manufacturing company, whatever that is. What is our world? What are we talking about? What are the specific entities that we refer day in and day out? If it's a product, well, what are the components of that product? What are the attributes of that product, and so on? That's the domain model. How do we take it into an ontology? First of all, what is an ontology? Well, you mentioned taxonomy. Let's start there. Taxonomy, it's a hierarchical view of metadata, right? You have the tree structure of the different attributes, different metadata. A good example is country, right? You can have a list of countries, you can have a list of colors and business units and so on and so on. All of these items compose your enterprise taxonomy.
I always use the example of region
Yes,
in the
perfect.
sense that country's simple because there's like a list of countries,
Right.
but it actually in practice when companies are getting a bit crazy is they go, okay, well, what are our regions? So
Yes.
where's North America? Where
Right.
is do we want to address the Nordics? Do we want to address Scandinavia? Do we want to address Europe? Like how does the world break down into groupings and subgroupings of countries? So
Right.
that's quite an interesting
It's
taxonomy challenge.
This is a very common one. And like, how do I find a document that's tagged for India, for example, when I'm searching for EMEA? Like, how does that work, right? So this is a
EMEA is Europe, Middle East, and Africa. For those who
thank
are
you.
not familiar.
Yes. Yes. So this is a challenge for taxonomy. So this is where we start talking about not only taxonomy, but more getting into ontology. So let's talk about ontology. An ontology is, in the very basic, simple terms, you can think about it as a taxonomy in 3D, because taxonomy is your parent-child relationship, the tree structure. An ontology really allows us to now provide different types of relationships between these things in our taxonomy. So if you had a list of countries and then a separate list of regions, now you can connect all the countries in a specific region outside of your parent-child relationship. So it really provides a different layer of different relationships for
So
your
the region
entities.
country thing is an ontology example,
It can be an ontology example, yes,
right? Because
depending on
there's
how it's implemented. But yes, absolutely.
okay.
And this is a very, very basic example of an ontology. We can talk about, so let's talk about a drug, right? In pharma, you have a drug, and there are so many different elements around the drug. So getting back to your domain, you had a little circle for a drug in your domain picture. Now we need to be able to define how this thing relates to other things, other entities in that domain, like studies, like participants, results, and status, and so on, but in a more granular detail. So when you're thinking about a domain, it's a high level conceptual representation of your domain, of your world. When we start getting into ontology, this is something that we actually can take in implementing our graph database. So it takes a domain and really gets into the detail of how specifically these things relate. Maybe even a little bit of engineering just to be able to be applied to the data in a more efficient way. But an ontology is ultimately it's a representation of entities, their attributes, and how they relate to each other. That's the data model for a graph database. And then once you apply that data model into the graph database and you have the data in that graph database, that's where you have a knowledge graph.
Okay, so there's a couple things. One is that I recently was talking to somebody, I managed to Google this in the interim, but I realized that I've been saying graph database for years,
Yeah.
not knowing why. It's called a graph database
Yeah.
specifically. As far as I could say, they might as well call it a strawberry database for
That would be a good one.
as much benefit as that word graph is adding. And
Yeah.
I Googled it and eventually found out why it's called a graph database. And there was actually somebody going back to the 80s talking about how unfortunate it was that we call them graphs
Yeah.
because most people don't think of graphs that way at all. So
Yeah.
when we think of the word graph, we think of graphic or graphical, something visual.
Yeah.
But it's a very nerdy mathematical term in the sense that it, like if you think back to geometry, you have functions like, you know, I don't even know enough math to come up with a function example off the top of my head, but you have something times something, for example, and that'll make a line. You can graph that function.
Yeah.
Also, when you have a system of these different things and their connections, you can talk about mathematically about how you connect between the different things in that system, and what falls within a certain group, and so on and so on. And unfortunately, that's also called a graph. And that's why it's called a graph database, because we have this idea of things and their relationships, and you can trace the relationships within it, hence graph database. One of the least intuitive terms in technology, I think.
Agreed. When I got into this, when I got into the graph database and knowledge graphs, in my mind was like, wait, isn't that actually a network? Like,
yeah,
literally, it is a network of things, how they connected to each other. That's what it is. But yeah, we're stuck with the graph term.
So there's that. I want to also use another example, just because we've talked about pharma a bit. I know we do a lot of work in pharma, but I want to give people another example of an ontology that I think everyone can relate to, because we've all owned some sort of complicated thing at some point. So if we had a manufacturing product, we can have graphs, or we could have an ontology, for example, that you have a product, and that product has parts, and you might need spare parts for that product. And those spare parts have certain availabilities, like where they're available in what countries.
Quantities, availabilities, variations as well.
Variations of the part that you can get. They all will have their price. They will have whether they're in stock or not, all this different information about a part. And they will break down. So you'll have like parts. You think of a car has an engine as a part, but an engine is a really complicated thing that breaks down to lots of other subparts. So that you have an actual the whole world of manufacturing. You can think about as another example of where you might have an ontology of the relationship between parts and spares and regions, and engineers that are certified to install that kind of part, and all these types of relationships.
Materials as well, like what is this part made of? What are substitute materials? What are the effects of that?
Exactly.
So it can get really complicated, but it's fascinating how it can actually describe the relationships between these things. And then the fact that this is now captured in a machine readable way can then allow us to really implement all kinds of use cases on the front end, whether it's a recommendation engine, whether it's just a website. Hey, my car broke down. I need this part. Making sure that part actually fits my car.
Yeah, I think that you dropped the word machine readable in there, which is one of the other things I wanted to bring up, which is that the part that I'm usually involved in is figuring out that domain model. But a domain model can live on a slide.
Yeah,
it can be a Miro board. It can be in a mind mapping tool. You can do domain models kind of wherever you want, because it's figuring out the things and the relationships, and you do that by talking to people, by doing interviews and getting subject matter experts in, talking to clients, and understanding the domain, the subject area that you're talking about. But you can't. That doesn't live in a database. It's a powerful thing. You will write better content, and you'll be able to have better insights and do things. But it's not machine readable. You can't use that to power anything. Hi everybody, just a quick reminder to say, if you're enjoying this episode and feel it brought you some value, remember to comment, like, share, subscribe on whatever channel that you're on. Also check out omnichannelx.digital for more info on our newsletter, webinars, and our on-demand learning opportunities. Now back to the show. Some of the kind of things we can actually power once we've got this thing machine readable. What can we do?
Yeah, so this is where the ontology comes in, right? Because ontology is machine readable. It is that data model that tells the machine saying, okay, well, if you have a drug, or if I have a part, that part can have all these different attributes, or it can have all these different relationships. It can be related to a different part, to a different product, and so on. So now the machine can really, the computer, the algorithm, can really look at a specific part and tell me, okay, these are the related items that are explicitly related. these are the attributes of this machine, this part, and actually present it to me. So as an actual true answer, and I'm specifically focusing on this because we're going to talk about this in a second or a little bit later when we talk about ChatGPT, for example. But this is curated information. This is actual true fact. And then what kind of things we can do with this? Recommendation engine is the very basic one. I mean, recommending. So if we're only talking about content, say you have a bunch of publications, articles, and actually we've implemented something like this for one of the development banks here based in this area. You have a bunch of publications from different sources. Then we need to be able to recommend based on who I am, based on what areas I'm focused on, my seniority level in the organization, what kind of articles or publications are relevant to me. So because we have the articles, because we have the metadata on those articles, because we know who I am, then we can make that matching and recommend content. From a parts perspective, we can, again, recommend the parts that are very specific to you, whether it's a monitor, whether it's a car engine, whether it's a pharmaceutical product, a manufacturer product that you need for your hospital machine, for example. Knowing all the details, all the attributes for that machine that you've already purchased and what's available out there, you can then make that match and say, okay, well, these are the specific parts, components, consumables that you need for your specific machine, rather than this is big manual that's 500 pages, figure out what you need.
And this huge catalog that goes with it, and
exactly.
you need to connect it to. So we're seeing a lot of that in manufacturing, where there's a lot of demand for this idea of the universal personalized hub, in the sense that I want to go in, and this would apply to any complex operation, but it's very obvious and clear in manufacturing. I'm going to repair this machine at this hospital, or at this airplane, or this Formula One race car, whatever it is, and I want to know exactly the parts I need, the spares I need, etc. And if I don't have them, I want to be able to order them while I'm reading through the procedures. So I'm getting I'm about to start a job, and because something's gone wrong, and it's gonna tell me right at the beginning, you're gonna need these things. Do I have those things? No, I don't. Can I order those things? How long will it be before I can get them, et cetera, et cetera, et cetera. So separating parts database or parts ordering, manuals, knowledge base, how-tos, all that, and bringing it all together in one world.
That's where the knowledge graph comes in, bringing it all in one world. We don't have to copy all the data into a knowledge graph, but we connect to it. We point to where things are, and that's the power of it.
I think we also should as the content model guy, I should bring this back to how does this relate to content types and deliverables. So if we have our parts and we have our spares, or we have our drugs and we have our studies, I mentioned that the different people will want to pull together content in different ways. I think people often get confused because it sounds like everything lives in the knowledge graph, and then people go, but why do I need a content model? Don't I just put all my stuff in the graph? But we're still, you could be writing a paper for one audience, like a presentation for a certain audience, or you could be writing an email newsletter, or you could be writing a formal response to a query. Like if someone emails you in, and you need to, you have a question, that you have to write them a response. You may mention many of these things. You might bring up lots of these facts and lots of these pieces of data, and you want them all to be accurate. You want them to be live linked to the source of truth. But the content that you write about them will be very, very different types, depending on the situations. Like your newsletter content, although it may mention the same facts, and in different ways, you're creating a content context when you in your content model, saying, okay, well, I want to write a newsletter, or I want to create a brochure, or I want to create a manual, or I want to create a knowledge base article. So those content types are things that live. It's a separate layer from your ontology of all the
Right.
data and facts, because
Mhm.
you want to just talk about your data and facts, but you're going to talk about it in lots of different ways, and you're going to talk about it in lots of different channels, and from lots of different departments in your brand. So whether it's, you can do this in one department, but at the end of the day, you're going to be producing lots of things at the end of the day. You're going to be
Right.
producing lots of different types of content that you deliver. And those different things, those are defined in your content model. And
Right.
they interlock with your data model in the ontology. So they're both can be done separately, but they're better together. They're chocolate and peanut butter.
Absolutely. So there are two general ways of thinking about this: knowledge graph or ontology. Let's talk about ontology and the content model. The content model can be really loosely integrated with the knowledge graph or the ontology because yes, you have an article, and the article is mostly text and not as structured as an ontology, for example. So an ontology that describes your product or your drug or whatever that is can say, sure, here's the data sheet or a publication article for that drug. And that points to your content model, to your content item in the content model. So that's an explicit relationship, but the overlap between data model or content model and ontology, it's loose, not quite there. Whereas when you're talking about a little bit more of a structured content, the overlap is a little bit more of an overlap. So for example, you have a product and you want to provide specific images for that product that are approved images. Specifically for regulated industries like pharma, this is huge, right? You have to use the approved images, approved information about a product, otherwise you can get in real trouble. So if we're talking about a drug or a
And also
product,
just for marketing, you want to use the right approved stuff.
absolutely
You don't
yes.
want to be selling pictures into sub-Saharan Africa with a bunch of Swedish models.
Right, definitely not. That's actually another good problem there. All right, so we're talking about a product, and you want to have specific images. You want to have the approved description of that product. Well, do you want to store that description in a graph database or a relational database, or you want to store it in your content management system? And that is the approved product description that may have a short description, a title, a tag, a tagline, multiple taglines depending on where it's displayed, and so on. So you have a
Multiple legal disclaimers.
legal disclaimer, absolutely. So from a content perspective, your content model will have a content type that says, okay, well, here's a product, and I have the title, the description, the short description, and everything else. Well, that same model is represented in your ontology so that the consuming applications know exactly what description to use, what image to use, what legal disclaimers to use, depending on the region, depending on the use case. So the content model and the ontology really overlap in that sense when your content is really structured, really well structured, and we want to provide a lot of personalization and customization on the delivery end.
Yeah. So we're doing projects these days. For example, if we keep with the pharma example, we have people who are talking about this stuff literally in PowerPoint, and they're getting tired of it because the same facts will appear in many PowerPoints, and and for example, you've got a citation, and you have to copy and paste the reference of where you got those facts at the bottom of every single slide that mentions them. The citation is not a thing. You can't. It doesn't live anywhere. You can't universally reference them. If you add another one to a slide, it doesn't automatically number them for you. So whereas if we move to a much more structured way of working, we can create slides, and we will make sure that all the citations are up to date. We will make sure that all the right graphics are being used for the particular region that you're delivering that stuff to. But
Yeah,
you could also express the same thing out as a website with the search box
exactly.
that will work on a phone. And you can't really do that unless you're actually structuring your content. If at the end of the day, you have this fantastic search engine or recommendation engine that goes, here's the best content, and they send you a PDF or a slideshow, that is not going to be able to deliver you the experience that you want to do in this decade and day and age. So this
You're
is
going to have
where
a lot of copy paste. Yeah.
Yeah, a lot of copy paste. So this is
Yeah.
So what either you copy paste like crazy and then review each copy so that you can have your different outputs that you want, or you just move to a different
Yeah.
base way of working, which is this structured way of working on the content side and a structured way of working on the data side. So I think you've nicely teed us up here. So we're taking about the merging of structure and data,
Yeah.
of content and data in structured ways, which takes us to the word on everybody's lips, which is AI, chatbots, and specifically
Yeah.
for some reason, AI and chatbots has kind of become synonymous with ChatGPT.
ChatGPT.
They kind of pulled a Google in the way that,
Yeah.
and now people just say ChatGPT when they really mean like large language model chatbots.
It's amazing. This has happened only in a few months,
Yeah.
3-4 months now. It's just it's phenomenal how quickly it rolls up.
So
But
how does this interact? How does this world
yeah,
interact with?
yeah. I've been thinking about this, and actually, my colleague Chris Marino recently published a blog about ChatGPT and whether it's ready for the enterprise. It's a fantastic blog. Actually, I read it recently in really good thoughts there.
Okay,
So
you gotta send us that, so we'll put it in the show notes.
I'll definitely will. I some thoughts from there. We'll touch on that, but ChatGPT is still young. It's the technology is very young, and we've seen it has a tremendous power, a tremendous potential, but it's not quite there yet, right? It can produce results that are actually not correct, not correct, and in an enterprise environment, that's not you can't do that, right? It still requires a lot of supervision. It has a huge potential in terms of content generation with supervision. That's in my mind. If you're generating content, you have somebody, the expert, needs to go through and update it and so on. Absolutely, there are use cases where this technology will fit really well, um, but at this point, it's still early on for full on enterprise adoption. Again, depending on the use case, there are use cases where it can really fit nicely, but from a regular enterprise level, it's still early on.
So let's do a quick definition before we get too deep.
Yeah,
So I mentioned large language model, chatbot, etc. So what, if you haven't heard already, if you've been hiding under a rock, so
yeah,
ChatGPT is a what's called a large language model based chat bot or chat interface. So it's essentially done in the same way that autocomplete has been working on your phone for a decade or
yeah,
so. And now what you see in Google, you have auto responses. You have these like quick, if you use Gmail or the Google Suite, I'm sure probably Microsoft as well. You get these kind of sentences generated and actually read the email, and it's kind of been creepy even for a few years now
yeah,
uh, how fitting the responses that it generates are.
yeah,
Where like it really will pick out like it'll send people condolences for bad
yeah,
news, and it will it will notice that something's supposed to be funny and offer you, oh yeah, that's really funny, as a response. So this ability to understand the language and pull out an appropriate string of words has been here for a while, and the large language model is basically just times 100ing that, so that instead of saying here's a probable word or sentence, we're getting up to long form answers, essay
right,
length answers, where it's basically it's a probability engine that says, based on what you asked, chances are this is what you want as a response, and it
right,
generates
right.
that from this enormous language model that it's created by scanning basically the internet.
It's a really fascinating technology. How they've implemented it is just out of this world. But yeah, ultimately, I actually saw a colleague of mine was joking about. So ultimately, this comes down to um, like anger pressing the autocomplete button, and it'll complete the whole sentence for you. Pretty much.
Yeah.
It really it basically, yeah, like you said, takes everything that you've written so far, analyzes it based on all the incredible amount of content that it already has as its learning base, and produce the statistical recommendation of what would be next, and then again and again and again. So it keeps going on that way. It is fascinating, no question.
So how can we? Well, I'm sure probably most people who have heard of it have also heard of the times it's gone crazy. So it's straight up made up facts.
Yes.
They actually they've already invented a term for large language model screw ups called hallucinations.
Oh, that's new. I didn't know that. That's cute.
Yeah, that's the term that they use now. So basically, you can, if you ask it for a list of 7 articles about the French Revolution, and it can only think of 6, it'll make up a 7th. It'll literally just make up the name of an article, and if you ask for more information about that article, it'll double down. It will give you a summary of that article. It'll give you when it was published, and none of this is real. It's all just grammatically correct hallucinations. Not acceptable.
From a business perspective, like I said earlier, yes, not ready there, not there. But from a technology perspective, I mean, think about this. There is something out there that can just make up stuff. It's like, wow, it creates its own thing. This is incredible.
Okay, so we're cutting in here. We've never done this before. We are jumping back in with Yanko. You're going to hear my audio a little bit different, and if you're watching the video, got a headset now. I'm actually in a different place. This is the first time this has ever happened. We were in mid-flow talking about this very, very quickly moving industry talking, and we were basically saying, as you've heard so far, that large language models are very powerful, but have some issues with reliability, traceability, provability. And to get them ready for the enterprise, the ideal would be if they were married with knowledge graphs that do have traceability and auditability and are using verified facts and connections. So I'm going to play you a little bit of audio from an announcement that happened in between when we recorded and in between and when we wanted to go live. This is not a promotion of this particular product, but it is it's an example of exactly what Yanko and I were predicting was going to be needed in the market. Oh, make sure that I'm sharing with audio. Yeah.
To build Copilot, we didn't just connect ChatGPT to Microsoft 365. Microsoft 365 Copilot is powered by what we call the Copilot system, a sophisticated processing and orchestration engine. It harnesses the power of 3 foundational technologies: the Microsoft 365 apps, that's Word, Excel, PowerPoint, Outlook, Teams, and more; the Microsoft Graph, that's all your content and context, your emails, files, meetings, chats, and calendar; and a large language model, or LLM, a creative engine capable of parsing and producing human-readable text, all accessible through natural language. It starts with a prompt from you.
So that's basically it in a nutshell. What we were saying is to make these systems enterprise class, they needed to be connected to the graph. So Microsoft has said your apps, your emails, your meeting transcripts, and that's fine. That's absolutely true. But the kind of technology that Yanko and I work on in these projects are not just ambient recordings. It's not just capturing email discussions and transcripts from meetings, although that is very useful. There's actually intentionally curated and loaded data. Yanko, you want to talk a little bit about the difference and how they fit into building solutions differently?
Yeah, absolutely. So like I said, it's been literally a couple of weeks and this announcement came up. The breakneck speed of this technology is just amazing. We talked about knowledge graphs and ChatGPT. So talking about knowledge graphs, you said it. We're trying to capture actual facts, actual information that is true, validated, curated, if you will, whether it's data or actual content as well. Knowledge graphs have that capability of doing that, both of them, integrating that information. But ultimately, knowledge graphs are a data structure, a data organization structure. You can connect all these entities and how they're connected and all that. But on top of that, you need to build a user interface, something that interprets that data. Knowledge graphs are really good for helping identify trends, for example, depending on the use case. There's so many use cases for
identify trends.
Trends, yes.
Yeah.
But again, we still need a front end to interpret that data. So here's where ChatGPT kind of technology can really come in and play really well. So this is what we were talking about a couple of weeks ago, and it's becoming a reality now, where you connect the front end, the large language model, to the actual facts, to the actual database, the organization of the data. And that way you can start interpreting that information. You can start getting the actual information from your data rather than something that could be unexpected. When the LLM is based on all the information on the internet, as you can imagine, it's not curated, it's not verifiable sometimes, and it's not always accurate. We talked about this a little bit earlier. Yes, ChatGPT 4, again, this was another release that since we talked about this originally. It's supposedly better at not making up things, but there's still a chance that it can introduce information that is not absolutely accurate, and at a business level, that's usually not acceptable. So this is where we still need the technology, the actual facts, the important information that's curated and accurate, and the efficiency of this new technology of LLMs, where it can create the text, create even contracts, and the different business cases. So marrying these together can produce really powerful system, powerful environment, if you will.
Yeah, and we talked about the idea that Google is going to be hot on their heels with similar announcements for their applications. And I think what's important to say that the point of this is not, and this happens often, like the first person to get out there gets mind share. The first brand to get out there gets mind share. But this is not a Microsoft thing. It's not just a Google thing. We're going to see this kind of technology be everywhere. I think someone could refer to it as the iPhone moment of AI, in the sense that smartphones had been around for years, but then the explosion happened and they became part of our daily lives, and just, we can't even remember really life before them. It's sort of a foggy memory what it was like before them. That's what we're seeing now. So it's not that everyone's now going to start using Microsoft Bing instead of Google, but that these applications are going to become ubiquitous as a layer for us to allow to do queries and kind of programming, things that only technical people could do before. But now, if you can express it in natural language, computers can do it for you, and that is going to open up a level of power and efficiency, which is going to be a leap forward.
Can't agree more. Even yesterday, I was chatting with some friends of mine, and we were thinking, hey, can you remember 20 years ago what was the work like? What was life like? And can you imagine 20 years from now, what is this going to be? It's just incredible. And especially with the speed that this is developing, it's just absolutely incredible.
I've been very I've been very lucky on my career that I was kind of straight out of university, ended up in this very tiny community where we were talking about things like we talked about, there was LANs, like a local area network, and then there was WANs, wide area networks. And in 2002, we were in a company where we were theorizing about, we're talking about PANs, and people like in the community were talking about PANs, the personal area network, where you would have these devices on your body that would be connected, and they would be able to leverage, the processing of one device would do things, and devices on your eyes and your ears. And what we now call having a Bluetooth headset, a smartwatch, and a smartphone. And it's just a normal thing. But all these things have been under discussion, and we're just now seeing the mass marketability of them.
Yeah, the way technology is evolving is just incredible. And like we've been talking about this, ChatGPT and large language models. It's really going to change the way we work, the way daily life is, really. I mean, imagine right now, ChatGPT is requiring a lot of processing power. It's not cheap. It's not something that an enterprise can just easily pick up and go unless they are ready to put in the investment in. But imagine in a few years when you have this in your phone, right?
Yeah.
It's very powerful. The question is how we really integrate it so that it is powerful in a useful way, in terms of getting the actual information, accurate information that you need in the right way.
So it also, I don't know if this is since we recorded, but very, very recently, it's hard to keep track. Things are happening in terms of days
Yeah.
instead of weeks. Since so we had ChatGPT 3 about 4 months ago, I think. It was right before. I think it was right before.
It's in October, November. Yeah.
October,
That's
yeah, and
when
then
it came out. Yep.
it all exploded right before
Yeah.
the holidays. And then we're already on ChatGPT 4. So about 5 months
Yeah.
later.
Yeah.
There was the, I think it was the Atlantic, if I'm not getting this right, but somebody made a prediction. One of these kind of tech houses made a prediction that to get this ChatGPT 3 level large language model down to something that was less than $1,000 to create and train and run was going to take till 2030. 5 weeks after that prediction, somebody at Stanford, a team at Stanford University, took one of Meta's AI models, so Facebook's AI models, and what they did is they got another AI model to train it, rather than having human trainers.
That's
and
incredible.
so within 5 weeks, they were able to get this new, well, not within 5 weeks, but 5 weeks after the prediction that they wouldn't be able to do it till 2030, they got this AI model, which wasn't even one of the more powerful ones. It was a more basic one. And they were able to more or less benchmark against ChatGPT 3. And they were able to do the whole project for $600 American.
That's incredible. Now, the researchers, they can do some incredible stuff.
Yeah. So this is running on a laptop at this point. This is running on a local computer for and $1,000 worth of like cloud computing, et cetera, services.
Yeah.
So as you were saying, having it on your phone in a couple of years is not unreasonable.
Right. Agreed. It's also a little daunting. Like, what are we going to do in a couple of years or 5 years down the road? Who's going to produce all this content? How are we going to know that this content was actually authentic, authored by somebody rather than something?
Mm-hmm.
Right.
And will that even be a criteria anymore? We had I talked about this on another podcast when we went through this with electronic music. We went through it with Photoshop.
Yeah.
And now we're doing it with words. I remember I was doing photography since I was a kid, and there was when Photoshop came out, that was cheating. You weren't a real photographer.
I remember.
Yeah. That wasn't real photography. The real photographers worked with chemicals and light and they made
dark rooms
and smells and film. Real photographers didn't do digital. And then the same thing with music. Electronic music was this kind of like, oh no, that's not real. That's not composing. That's not art. And the same thing. It just kind of you need to get over the cultural barrier to this feeling of, well, we were always doing it this way, this new way. That can't be right. That can't be acceptable.
The only difference here is that with music, with photography, it's a one specific area. With this, it has an impact on everything.
Everything.
It really can transform industries, not just how we work, but industries.
Entire economies.
Yes, absolutely.
Yeah.
I mean,
so we got to try to wrap this up. I think we could talk for a whole other podcast about this and all the implications. This, as we said, things are moving so fast.
Yeah,
it's been so great to have you, Yanko. I think we'll have to have you back before the end of the year to do like a roundup. How did this turn out in a few months' time? But thank you so much for your contributions, and thank you everybody for listening. Remember to check out the rest of the podcasts on OmnichannelX.digital. And we're going to be announcing some themes for the year. We're doing some different themes like content modeling and pharmaceuticals, where you can get lots of different resources, podcasts, webinars, etc., all year long. Check that out. Subscribe for our mailing list. If you like this, give us a like and a comment, and let us know what you want us to talk about next time we get Yanko on the show. Thanks so much.
Noz. Thanks, everybody.
Cheers. Bye-bye. Thank you for listening. This has been the Omnichannel Podcast with your host, Noz Urbina, founder of Urbina Consulting. Let us know on LinkedIn or Twitter what you liked from this episode, what you think we missed, and who you would like us to interview next. Now that you've heard what we're passionate about, you can also check out urbinaconsulting.com to find out a little bit about what we do. Thank you so much, and see you next time.